Welcome to section 6 of Data Network Security 1. In this session, we'll be dealing with insecure direct object referencing. Now, at the end of this session, students should be able to explain insecure direct file reference. We should be able to also exploit insecure direct file reference on the demo site, which is altoromutual.com. Now, what is insecure direct object reference? Now, with this, part or all of a resource name controlled by the user input is being seen. So we are talking about the file, table structure, and what have you. And proper access control checks are not in place. Now, what happens is that a user or an attacker gets access to a system file, which gives it the path to most of the resources in a user's site or a user's web application. Now, what are the implications with insecure direct object reference? Now here, once your session ID is in the known or is in the URL, the attacker is able to access user's account, or you're able to get access to another account. Here also we have direct access to system resources. So for example, we have the /boot.ini, and this gives you access to kind of like the root folder of your system. Some implication also involves information leakage, which the attacker can use for future attacks. Now, insecure direct object flaws results as in an authenticated web application user having unauthorized access. So that results in one not having an access to a site, but gets the opportunity to attack that site. So we are looking at access to privileged account functions and information. Now, poor design and some misconfiguration of data objects such as files, directory, and database keys within any development can allow an attacker or user with low account privileges to bypass all the application access controls. So one doesn't have access or the authority to access some part of or all of an application, a web app. But one way or the other, the user gets to do that, or the attacker gets to do that. Now, this is what we are calling insecure direct object reference. Now, users can exploit this type of weakness by changing parameter values to directly refer to objects the user is not authorized to. So if I'm supposed to just do a login and check my bank account, that is as far as I go. I don't have the authority to go beyond that, and that is where the insecure direct object comes in. So developers can safeguard against this by ensuring that all access controls are checked and invoked with all user objects. Now let's take, for instance, this website, www.altoromutual.com. Now here we are looking at the URL. Now the URL suggests that we have a .htm file. So this page serves up HTML content and the question is, can it also be made to show the content of other files? It's possible. Once an attacker gets to know the format of a URL, it means that once the URL is exposed, then the attacker can modify the URL to suit him or herself. So for instance, in this example, we have boot.ini. So this is an attempt to access the boot.in file. So once that application prevents this file because it's supposed to be a text file. Now let's look at the other example. If I modify that URL and I do a /boot.ini with a percentage sign, 00.html. This tricks the server into seeing this request as an HTML file or HTML file. And this works, but it only gives, or it doesn't give the full path to the system. This suggests that if I add a dot / to the request, I can actually get to the right directory. Let's see that in the next example. Once that is done, we see that the boot.ini details are displayed. It means that for this particular site, it is exposed because we've gone through the URL into the directory of the website. How do we prevent insecure direct object reference? We have to try to avoid exposing object references such as the primary keys or file names. Validate all objects and use a positive security model to accept only good object references. And we must always verify authentications to referenced objects. Now, the best solution is to use an index value or a reference map to prevent parameter manipulation. So an example is shown down there. We have www.example.com/application file equals to 1. So that's indexation. We've indexed this site. So we are using the value 1. Now, if you must expose some direct reference to the data structure or database structure, then we have to ensure that the SQL and other database access methods only allow authorized records to be shown. And an example is shown down there using the int cat ID and what have you. We have a select statement also in there, SQL string in there. Now, once you go to Sakai and you go to lab 4, you'll be able to exploit insecure direct object referencing. So upon completing this exercise, you will be able to exploit that part of the vulnerability with regards to insecure direct object reference. So in this session, we've been speaking about insecure direct file reference vulnerabilities, how to assess or to the ability to access or the ability to get access to resources in controlled, which is being controlled by user input, and that access is not verified. We've also seen how to exploit insecure direct file referencing on Atoro Mutual. Here we have accessed sensitive Windows files on the server and steps required to fix insecure direct file reference vulnerabilities. And this is the same fix as malicious file execution. That brings us to the end of section 6. I'll see you in section 7.